So first, what is the meaning of unit cell? First, you have to know that what is the meaning of unit cell. Actually, this is the smallest unit cell, the smallest repeating, the smallest repeating unit or unit in space. Actually, the unit cell is the smallest repeating unit in space, where this one, the unit cell, it will continuously repeat it over and over, and it will make the crystal. Here, this is the figure of the crystal. This is your crystal that I have drawn here. So this 1, 2, 3, 4. This makes one unit cell. This is your unit cell. So unit cell. So different unit cells are there, and this unit cells are regularly arranged, and it will make the crystal. This unit cell regularly arranged, it will make the crystal. So this is the unit cell. So if we will take one unit cell, this is one unit cell, two different unit cells. So suppose you will take the one unit cell here. What happened? I will take this side as the x-axis, this side as the y-axis, and this side as the z-axis. Suppose I will draw this figure like this. This is the figure, and this is the A point, this is the B point, and this is the C point. So this point, A point, has the parameters A, and this side the parameters B, and this side the parameter C. So this is the three parameters in for this one, this x-axis, this is for the y-axis, and this is for the z-axis. And A, B, C for the x-axis, y-axis, and z-axis. These are called the parameters. These are called the parameters. So in one parameter, in one unit cell, I have the different ABC parameters, and there is the angle between them. That is x and y axis. Angle between them is this is your angle gamma. This is your x to z. This is your beta, and B to C. This is your alpha. So this is your three angles: alpha, beta, and gamma. So these are the alpha, beta, gamma. These are the angles, and these angles also are the parameters. These are also the parameters. There is 6 parameters are there. These are the angle. These three things are the angles. Now come the primitive translational vector. Primitive translational vector. What is primitive translational vector? That is inside that the unit cell. Actually, when we are knowing that translational vector, it will satisfy n1a plus n2b plus n3c, as you know that. And this equation satisfies for integral. Satisfy for the integral value of n1, n2, and n3. Then it is called the translational vectors. A, B, C. This A, B, C are called the primitive translational vector. Primitive translational vector. Okay. So now come to this is your for the 3 dimensions. This is for the 3 dimension. This equation is for the 3 dimensions. So this is unit cell. Any regular alignment of this one unit cell, they are repeating over and over. This is the formation of what? Crystal. now comes the another thing that is inside the unit cell, that is called the primitive cell. What is primitive cell? Primitive cell is what is? Okay. So as I have told you, we are regularly take this one, arrange here. Suppose you are regularly arranging there, and we draw the figure here like this. This is this one which we have taken. This is called your primitive cells. That means that will consist of a one atom. This cell consists of one atom, that is called the primitive cell. Suppose you will take this one, the different arrangements. So this is not called the primitive cells. So primitive cells, this consists of one atom. If it is consist of one atom, it is called the primitive cells. And more than one, it is one atom, it is called non-primitive. It's called the non-primitive cells. Okay. So there are two-dimensional primitive cells are there. So two-dimensional primitive cells are there. How I can draw these things? There are, this is your two-dimensional primitive cells are there. This is the parallelogram. This is called your monoclinic. Then another is there rhombus shape. This is rhombus. This is called your orthorhombic. Then there is a rectangle. This is a rectangle. This is your also orthorhombic. Then square. This is actually, these figures are for the two-dimensional. This is for the two-dimensional tetragonal. So this is for the two-dimensional primitive cell. So that we will confirm that if it consists of one atom, that is called your primitive cell. If it is more than one atom, it is called the non-primitive. Lattic points. These are the lattic points. Here also there is lattic points are there, and they have the contribution. Lattic point have the contribution. What is contribution? Suppose I am taking the monoclinic. This is the lattic point, and lattic point. So what happened? And this has the value 1/3. This is the value 1/6. This is the value 1/3. And again it is the value 1/, sorry, this is 1/6 and this is your 1/3. So when we add these things, 1 by 3 plus 1 by 6 plus 1 by 3 plus 1 by 6, the value will come the 1. That indicates the values of this your monoclinic or any unit cell is 1. This is your solid state 2-dimensional primitive cells. Okay. So if it consists of more than 2 atoms, that is in case of the non-primitive, 1 atom plus the value of this one, it will come to the 2. Okay. So now there is a one important things are there in the unit cell. Let's come to the important things of the unit cell, and that is called your Winger-Seitz cell. Winger. What is Winger-Seitz cell? Here what happens? Suppose as you have know the different regular arrangements of the atoms are there. So when we will take the arrangements clearly, what happens? The definition for this one, how we can arrange this one. This is the special type of primitive cell. Special type of primitive cell. When lattic points are not in a kernel, lattic points are not in kernel, that means in middle you can take when the lattic points are not in kernel, and we make a primitive cell, then it is called Winger-Seitz cells. That means when the lattic points are not in the kernel, then we make a primitive cell from there. That means one thing is that it will be not in the kernel. So that type of special type of the primitive cells is called Winger-Seitz cells. Okay, how I can draw these things? So this size also. Suppose I will take this one, this point, this side, this side, this side, this side. So all the sides is the normal, and half of this one, and this side half of this one, this side half of this one, half of this one. So in every side, so this half, high contrast this in the least kernel. We have this the point. I have taken this side also. This side first, from this point to this point, from this point to this second one, from this to third one, fourth one, and this one fifth, this was sixth, and this 7, and this is the last one, this is the 8. So of this point, all have the same distance. All have the same distance. So what happened? The middle of this one, this is the normal. Suppose I am taking this point, this line, the half of this one, this is the half of this, the half from the half, this is normal, from the half, this is normal, from the half, this is the normal, from this line there is half normal. So in every point, every line we have taken the normal. In every line, in the half of this line, there is the point I have taken, that is your normal. So what happened? Then there is the making of one type of your cell, and that cell is called the Winger-Seitz cell. So very important for us, the Winger-Seitz cell. This one, this arrangement This arrangement is called the Winger-Seitz cell. So this is also the one type of the unit cell. So here we able to know the what is the meaning of unit cell and what is the crystal, how the unit cells are forming the crystal, then primitive translational vector, then what are the parameters of this unit cells, then how their angle is forming, then special type of the unit cell, the Winger-Seitz cells we are able to know from this one. Okay.